Hello everyone, welcome back to Think Lab by Saurabh. So in today's video, we are going to explore one of the most fundamental concepts in artificial intelligence, the types of learning in AI. So if you want to truly understand how AI system works, you must understand how they learn from the data. So we will go from the basic intuition to technical depth step by step. The first question is, what is a learning in AI? So in AI, learning refer to process where a model improve its performance based on experience data or some kind of data. So formally, a program is said to learn from the experience E with respect to some time T and performance measured by P. So if performance at task T measured by P improve with experience E. So this definition come from the, one of the famous machine learning concept, right? So I think this concept is given by the Tom Mitchell. That was the one of the great scientists in the machine learning. So this concept is given of all the kind of learning, like how can we say the learning it happens with experience E, performance P, and with respect to some task T, right? So we have this. Now we are going to discuss about the supervised learning, right? So let's start with the most common learning is supervised learning. So in supervised learning, we train a model using the label data. So this means each input is paired with the correct output. So mathematically, we can try to learn from the function fx, y. So where x is the input and y is the label. So the goal is to just true function that map input to particular output. So we define a loss function. We can define a loss function such as mean squared error or cross entropy, and optimize model parameter using the gradient descent. So in a supervised machine learning, there are two types. One is called classification for the discrete output and regression for the continuous output. So example, if we can take the example like a spam detection, image recognition, and the price prediction. So these are the example of supervised machine learning. So now we are moving to the unsupervised learning, right? So let's move to the unsupervised learning. So here the model given the unlabeled data and there is no correct answer. So the model must discover the structure on its own, right? So the objective is to learn the underlying distribution of data. So there are key techniques include like clustering. So clustering, what is the meaning of clustering? So grouping similar data point like k-mean clustering, hierarchical clustering. Now we are moving to the dimension reduction. So reducing the features like PCA, PCA are one of the most popular dimension reduction technique. Now we have to do the density estimation. So unlike unlike the supervised learning, there is no explicit loss based on the label, but we optimize the internal matrix like the variance or distance, right? So now we are going to discuss about the reinforcement learning. So next is the reinforcement learning, which is the fundamentally different. Here an AI agent interact with an environment over the time, and each step the agent observe the state, take an action, and receive the rewards. So the goal is to learn a policy, right, that maximize the cumulative rewards. And this model is using the Markov decision process, MDP, right? So there is a concept of state, action, transition probability, rewards, and discount factor. And there are lots of example of this there is example of reinforcement learning is the q learning deep q network here we call it DQN or policy gradient method. So in the application including the robotics, game AI in the autonomous driving, so these are the application of reinforcement learning. And mostly this model use this Markov decision process. We in this Markov decision process we have a SAPR, and this there is a discount factor we call gamma, right? So now we are moving to the next learning we call the semi-supervised learning. So now let's talk about the semi-supervised learning. So this approach combine a small amount of labeled data and large amount of unlabeled data. So why this is so important? Because labeling data is expensive and the time consuming. So the idea is to just structure from the labeled data to improve the supervised learning performance. So this technique includes the self-training, co-training, and the graph-based method, right? So now we are moving to the self-supervised learning. So one of the most powerful modern approach is the self-supervised learning. So here the system generate its own label from the raw data. You could take the example like predict the next word in a sentence, mask some token and predict them, right? So formally, so this how the large language model are trained. So large language model generally use the self-supervised learning for the training purposes. So formally we design the pre-text task where the label are automatically derived, and this allow model to learn this rich representation without the manual notation. Like if you check the BERT GPT, like so BERT they use the BERT use the masked language modeling, and the GPT use the auto regressive modeling, right? So now we are going to just perform the comparison and key insight of all the kinds of learning. So supervised learning, we learn from the label data. Unsupervised learning, we try to find the hidden structure, right? And the reinforcement learning, we learn from the interaction. And the semi-supervised learning, we try to perform the hybrid approach. And the self-supervised learning, which generate its own supervision, right? So now we are going to summarize the video, and key insight from this video is the choice of learning is depends on the data availability and the problem types, right? So AI is not just about the model; it's about how the system learn, adapt, and improve over the time. So understanding this learning, is the foundation of mastering the machine learning and AI. So if you found this helpful, so don't forget to like, share, and follow the Think Lab by Saurabh for more depth content. And thank you for watching. See you in the next video. Happy learning.